I'd like to welcome you to the introduction of the first IEEE Expert Now e-learning tutorial on sustainable green engineering. This is the first of two interdisciplinary engineering courses developed by Paul G. Ranke. Now, Paul is the IEEE Green Engineering Editor and is also a full tenured professor at NJIT, New Jersey Institute of Technology in New Jersey in the United States of America. Now, on the left, top left corner, you see an old typical European automobile. And on the right-hand side, you see an electric car, a very modern electric car. And these are two extreme examples. The old car obviously had a very poor fuel consumption record, and also pollutant, toxic gases are leaving this car, whereas the electric car is actually charged based on electricity that was generated in solar panels. And it has zero emissions, and it's a plug-in electric car, so therefore the sun is providing the fuel. So again, it's the perfect solution because you have zero emissions as well as the benefit that the sun is providing you the expense of the fuel. Another set of examples. On the left-hand side, you see this tremendously polluted, toxic, dirty factory. And on the right-hand side, you see solar panels and behind them a wind turbine. I think this is a very good contrasting view of the past and the future. It's not just what we've actually done, but it also carries a huge morale in the sense that never forgets that the toxic factory was approved by several engineers and accountants and bankers and architects. In other words, it's terrible that it actually happened. It's terrible that they didn't realize that there is something to be done here, and we can't just put all those pollutants onto the streets and eventually kill all those people around the area. So this means that green engineering is a much, much bigger idea and challenge than just producing biodegradable fuel or biodegradable materials or non-toxic computers, because it has this environmental responsibility, the stewardship that has to go with it, and throughout multiple life cycles. And we're going to talk about that a lot. So on the right-hand side, you see the future picture, which is the solar panels with the wind turbine, basically using nature to produce all the energy so we don't have to put all the toxic waste into the environment. As you can see, to summarize, our goal is to improve the quality of products, processes, and service, to simultaneously reduce costs, pollution, the carbon, and the environmental footprint, including raw material processing. In other words, we start with mining the material that we're going to be using, because that's the fair way of assessing the entire life cycle, and then multiple life cycles. So we would like to include the raw material processing, design, manufacturing, maintenance, reuse, recycling, and the entire multiple life cycles, not just one. In other words, you have a brand new computer and then maybe use it for a couple of years, and after that you throw it away. Well, don't throw it away, because think of reuse, recycling. Think of multiple life cycles, and that is another very important way of thinking and changing the thinking. And then, of course, when you design like this and manufacture like this for multiple life cycles, then issues come in like design for disassembly. Not just design for assembly and design for manufacturing, design for disassembly. You don't want to pollute and kill those assembly line associates or disassembly line associates who actually do this. So that's why I'm saying this is a huge, huge challenge, because now we're affecting practically everything that we've done so far. And this is why it is such an exciting opportunity to get involved in green engineering, because we have to really rethink everything we've done in the past and to do it much better in a much more sustainable way. Obviously, we have to, and we will, and we do offer some analytical as well as practical strategies and methods on how to eliminate waste, how to enhance quality, how to deliver value to customers, while achieving environmental performance goals and earning higher profits than as with non-green engineering approaches. Because there is an enormous opportunity here in terms of making money, and there's nothing wrong about that, as long as it's done in an ethical way, as long as it enhances life, quality of life, all those nice things that engineers are famous for, ethical approach to the environment, and ethical approach to the world, and try to create goals and results that support all this. So that's what green engineering is all about. So to summarize, our goal is to understand that fundamentally sustainable green engineering means waste reduction, and it's a multivariable optimization challenge. It's n-dimensional space, very complicated, and every variable is a distribution, and we don't quite understand the upper and lower control in it either. Okay, so it is a very complex issue where the objective functions are often dynamically changing. They're fuzzy and not even known in many cases, so we have to gradually work at it. But I'm very positive that we can crack this challenge as humanity. We have to. So sustainable green engineering advocates learn Six Sigma concepts. These are random methods, statistical quality control methods, for example, that we could apply through all levels of the life cycle of any product, process, or service system. And there are other methods as well, but this is a fundamental method that we will rely on, and the module is designed like this.